So, you've heard the buzz about quantum computing. Well, today, we're going on a journey into what is, no joke, one of the most revolutionary fields in technology. And this isn't just about landing a new job, it's really a call to adventure, a chance to get in on the ground floor of the future of computation itself. Let's dive into the roadmap for becoming a quantum specialist in 2025. Okay, so what is all the excitement about? It really starts right here with the absolute basic building block. A classical bit is pretty simple. It's just a switch. It's either on or off, a 0 or a 1. But a quantum bit, or qubit, it can actually be both 0 and 1 at the exact same time. This totally mind-bending property is called superposition, and it's the secret sauce that unlocks all of this insane quantum power. And when I say power, I mean a leap so massive it's almost hard to wrap your head around. We're talking about the ability to solve problems that are literally impossible for even the fastest supercomputers we have today. This is going to transform everything from medicine to finance. Now, let's talk about the payoff for mastering this new frontier. The demand for people who know this stuff is so high that top-tier specialists can pull in annual salaries well into the six figures, and honestly, often a lot higher. This is the tangible reward for being on the absolute cutting edge. But why are the salaries that high? Well, just look at this number. Across the entire world, there are fewer than 50,000 skilled quantum professionals. That is an incredibly tiny talent pool for technology that's poised to change everything. So, you know what that means. It's a classic, textbook case of demand just crushing supply. For anyone looking to build a high-impact, genuinely future-proof career, this is one of the biggest green flags you could ever ask for. You'd be stepping into a field where your skills are rare, incredibly valuable, and desperately needed. So, what does a specialist actually do all day? Well, think of them as the bridge. They stand between the super weird, complex world of quantum physics and practical, real-world answers. They are the architects, the designers, the engineers who build the algorithms that will run on these amazing new machines. Ready to get started on the journey? We've broken this roadmap into 3 acts. We're going to kick things off with Act 1, which is all about building that rock-solid foundation. Because, you see, before you can start manipulating qubits, you got to learn to speak their language. And that foundation really rests on 2 main pillars. First, you have to get comfortable with the physics and the math that basically run the quantum world. And second, you need a deep understanding of classical computing, because quantum systems don't just exist on their own. They have to work hand in hand with the computers we use every day. Okay, so let's break down that language. Linear algebra is absolutely essential. Qubits are described with vectors, and the things you do to them, the operations, are matrices. Things like superposition and entanglement, that's basically the grammar of quantum mechanics. You just have to know this stuff. It's completely non-negotiable. Now, on the programming side of things, Python is the undisputed king. No question. It's pretty easy to learn, and it has these powerful libraries like NumPy that make it perfect for getting into quantum development. Sure, other languages like C++ are used for the really heavy-duty simulations, but if you're just starting out, Python is where you want to put all your energy. All right, you've built that solid foundation. Now you are ready for Act 2, actually stepping into the quantum realm. This is where the real fun begins, because we're going to apply all that foundational knowledge to specifically quantum ideas and tools. This act has 3 really important steps. First, you'll go way deeper into how qubits and these things called quantum circuits actually work. Then, you'll study the famous algorithms that give these computers their superpowers. And finally, you'll learn the software frameworks that let you write actual quantum code. And this table perfectly shows off those superpowers I was talking about. Shor's algorithm, it could, in theory, break a lot of the encryption that protects our online banking and private data right now. Grover's algorithm can search through huge databases exponentially faster. These aren't just small improvements. They are total game changers for some really critical problems. So how do you actually use these powerful algorithms? You use one of these software development kits, or SDKs. The easiest way to think of these is as your quantum toolkit. IBM's Qiskit is a fantastic place to start since it's built on Python and has a massive community behind it. But really, all the big tech players have their own powerful versions. And now we get to the most exciting part. In Act 3, we close the gap between learning and actually doing. It's time to take all that theory you've learned and turn it into real, hands-on experience. This is what turns you from a student into a real practitioner. So the path forward involves three key moves. First, you got to get your hands on some actual quantum hardware, which, believe it or not, is way easier than you think. Second, you build some projects to prove you can use your skills. And third, you go get certified to validate that expertise.
This is just incredible. I mean, 10 years ago, getting access to a quantum computer was a physicist's wildest dream. Today, thanks to the cloud, you can run experiments on real quantum processors right from your laptop. Companies like IBM, Amazon, and Microsoft let you access their machines through these platforms. It's amazing.
And here's a really important pro tip. Don't just stick to the simulators. Running your code on the real hardware is so important because you'll immediately run into real-world problems. Things like noise, which is just tiny disturbances from the environment creating errors, and decoherence, which is when a qubit forgets it's a qubit and just acts like a normal bit. Learning to deal with these imperfections is a huge part of the job. Need some ideas for that portfolio? Hey, start with something foundational, like a true quantum random number generator. Then maybe you can move on to more complex stuff, like simulating secure communications with QKD, or even dipping your toes into quantum machine learning. Trust me, these are the kinds of projects that are going to get you noticed. So, after you've completed this whole three-act journey, you finally arrive at the destination, a future at the very forefront of a technological revolution. This is the big reward for all your hard work. Let's take a look at what that future actually looks like. The places you can apply these skills are going to be incredibly broad. The world of finance needs quantum for better risk modeling. Healthcare needs it for discovering new drugs. Cybersecurity needs it to develop the next generation of encryption. You're not going to be stuck in one industry. You will have your pick of the litter. And just look at these job titles. They reflect the incredibly high level of expertise we're talking about. You're not just going to be a programmer. You'll be a quantum algorithm developer or a quantum AI researcher. These are roles that are focused on deep, boundary-pushing work. You know, the ultimate takeaway here is that this career path is so much more than just a job. By becoming a specialist in this field, you are literally helping to build the next era of computation. You're one of the pioneers who is shaping the future of intelligence itself. So that's really what it all comes down to. The quantum revolution isn't a question of if anymore, it's a question of when. The foundations are being built as we speak. So the real question is, for you, are you ready to be one of the people who builds it?